Okay, we are recording. So I was showing you last time how we can use a real Cisco router to configure, no? So I was telling you that we cannot buy those devices, they are very expensive. So if we want to do a practice with real devices, it will be complicated. But in the past, they will do, the university will buy like maybe 10 and we'll do practice. But it was one router for 2 students. It was not good. Today, we do something that is much better. So we are going to do a first lab. Let me bring the lab here. That will include some Linux machine and some on one Cisco router. It should be this one. Let me see it. Oh, this one is too complex to start. So this one. Yeah, this one is just perfect to start. So let me bring it inside the virtual machine. Okay, so we are going to use GNS3. I already showed you GNS3, no? So I just drag and drop the PDF file, so I have it inside my virtual machine. I'm going to double click it. So we want to make this configuration. So as you can see here, we have 3 networks. The first network here, which is connected on the fast Ethernet 1.0 of router 1. This network is the network 10.1.1.128/25. So PC5, PC6, and this interface of the router belong to this network. Remember that the switch is transparent. It's like it is not there. There is a second network here, which include PC1, PC2, and this interface of the router, fast Ethernet 2/0. And this network is the 192.168.0.0/24. And we have a third network, which include PC3, PC4, and fast Ethernet 0/0 of the router. This time the router is going to be a Cisco router. We are going to use this model, a 3640. So let's first do this topology in GNS3. So I'm going to start GNS3. I'm going to create a new project. Let's call it Cisco Debian 01. So at the beginning, of course, it's going to be an empty project. And then I'm going to start putting the devices that I need. So I need 6 PCs. So I'm going to go here in the end devices, and I'm going to use Debian 7. I'm going to rename the PC like PC1. And I'm going to start duplicating PC1. So a first duplicate, we have PC2. Another duplicate, we have PC3. Another duplicate, PC4. Another duplicate, PC5. And the last duplicate that I need for PC, which is PC6. We need 3 switch, as you can see. Switch 1, switch 2, and switch 3. So I'm going to go here where we have the layer 2 devices, and I'm going to take an Ethernet switch. I'm going to change its name as S1, or maybe SW1 as it is in the graphic. So I need 3 switch. So I'm going to duplicate it. I have SW2. As you can see, it was just created. I'm going to duplicate one of the switch, and I got SW3. And I need a router. So here, they say that we should use a 3640. So on the size here of the router, we have several routers. So the first one is the 3640. I'm going to drag one in my working area, and it's called R1 by default. So now I'm going to order a little my devices, so it's look what we need at the end. So here we need PC3 and PC4. We need another switch. Here we need a switch, and we need PC5 and PC6. So let me put PC5 here and PC6 here. Okay, I'm going to use these tools that allow me to create UTP cable. So I want to go from PC1 that have just one interface to any interface of the switch. Doesn't matter which one you select. From PC2 that have just one interface to any of the 7 interfaces of the switch that are still free. For example, this one. I need this connection. So I forgot something. This is a modular router. And in this modular router, there is no fast Ethernet interfaces. So I need to simulate that I'm going to open it and insert in the free slot some networking cards that are called, here they tell you, network module 1 fast Ethernet TX. So look how we are going to simulate that. You are going to right-click the router and go to configure. And in this part that says slot, look at all the slots that we have, and they are empty. So in the first slot, you can put any of these networking card, network module. I'm going to put, because they say use 3 network module 1 fast Ethernet TX, no? They say here, use this router, remember to install additional module, network module 1 fast Ethernet TX in your router R1. So I need 3 of this module. So one is in slot 0, the other one is in slot 1, and the third one will be in slot 2. I'm going to click here, OK. And when you put the mouse now close to the router, this pop-up window will tell you here, okay, it disappeared when I tried to go, that we have a fast Ethernet 0/0 port, a fast Ethernet 1/0 port, and a fast Ethernet 2/0 port. So I'm going to go back and take my tools that allow me to create UTP cables in general. And I need to go from this interface, it's very important, I need to go from fast Ethernet 2.0 to the switch. So here, when I click, I will see the 3 interfaces that are still available. And of course, I have to select fast Ethernet 2.0 and go to any interface that is still free on the switch. So it doesn't matter which one you select. So we have the cable. Then we need to put a UTP cable between router 1 and switch 2. And on router 1, we need to use fast Ethernet 0/0. So I'm going to click on router 1. As you can see, this interface is still empty, still not connected. I'm going to select this interface, and any interface of the switch will be OK. Here, I want to connect the switch to PC3. So any interface of the switch to PC3. I want to connect the switch to PC4. So any interface of the switch to PC4. OK, I've done this part of the connection. Now I want to do the other part. I need to put a UTP cable from the router to switch 3. And on the router, I'm going to use fast Ethernet 1.0 as an interface. So I'm going to click on the router. There is only one interface that is still available, which is fast Ethernet 1.0. And I'm going to go to the switch and click on any interface will be OK. Then I need to connect the switch 3 to PC5. So any interface of the switch to PC5. And then I need to connect PC6 to the switch. So there is only one interface in PC6 to any interface of the switch. OK, I'm going to put this name here. It's a little better here. This name here. OK, we have our topology. It is done. So we can now power on the devices. So I'm going to power on PC1, on PC2, and I'm going to start configuring them. So I double click on PC1 once it's powered on, so I can see the screen of PC1. Let me double click also on PC2. Here is the screen of PC2. So they are booting, which means that they are starting the different daemon that they need to operate correctly. So PC1 is already ready. I'm going to do a bad practice. You should not do that. I'm going to enter as root, so we lose a little less time, and the password is tour. But you should not do that. No, you should enter as Eric, which is a normal user, and then you sudo. Every time that you need to do an administrative command, you can use the sudo command, or you can switch the user to an administrative user. If I type ID, I am the root user in this moment, so I have all control over this PC. So the first thing that I want this PC to be named PC1. The default name is Debian. I don't want this name, so I want it to be called PC1. So I'm going to type hostname PC1. And it will not update the prompt. And the prompt was received when I start the shell. So I can exit here. As you can see, it knows that its name is PC1 and come back. So I restarted the shell, and the shell now have the prompt with the correct name of the device. Okay, I want this to be persistent, which means that if I boot PC1, I want the name of PC1 to appear again. So I need to edit two files. The hostname file, the etc hostname file. This is the name by default. Let me remove it and put PC1. And there is another file that I need to update, which is the etc host. So here, instead of Debian, I'm going to put PC1. And here also, so this is the short name, and this is the full qualified host name. FQHN, full qualified host name. Let me save it. I'm using VI, but remember, use nano, which is much more easier to do your modification. No, when you want to exit with Control X, you can exit nano. Okay, so PC1 already have the correct name, but it doesn't have the correct IP address. So look at, for example, in ETH0, which is this interface, it don't have an IPv4 address. It does have an IPv6 address, but it doesn't have an IPv4 address. The IPv4 address will be identified by inet. So in the loopback interface, it does that. The PC have one IPv4 address. So I need to put on Ethernet 0 this IP address, 192.168.0.10. So I'm going to edit the file that corresponds to that, which is /etc/network/interfaces. And here, instead of DHCP, I'm going to put static address and the IP address that I want for PC1, which is 192.168.0.10. Then the net mask appear here. It's a /24, so 255.255.255.0. And then there is something else that I need to configure in PC1. What will it be? I need to tell PC1, if you want to reach a device that is not in your local area network, send it to R1. Which means that if PC1 have a packet for PC5 or for PC6 or for PC3 or for PC4, I need to tell PC1, you have to send it to R1 first, and R1 will forward it to the destination. So we saw last time one way to do it. So we saw, for example, we can write here up route add net 0.0.0.0/0, which is the default route gateway GW. And router 1 have 3 IP addresses, one here, one here, one here. So if PC1 want to send something to R1, it have to send it to this IP address, because this IP address is in the same local area network where PC1 is part of it. So we are going to put here 192.168.0.1, which is the IP address of Fast Ethernet 2/0. Okay, this is the configuration of PC1. So I did change this file, the etc network interfaces, to tell PC1 that I may change. I can do IF down ETH0 and then IF up ETH0. So after doing that, look at, we didn't have an IPv4 address before in ETH0, and now we have it. And this is the mask associated with the network. No? So good, PC1 is ready and is functional. Let me do the same thing for PC2. So here I just went and sit in front of PC2. I'm going to enter as root. I should not do it. I'm going to change the host name and call it PC2. Let me exit, re-enter. So the bash have a updated prompt, and we can see on the prompt the username is reflected at the name of the PC. Okay, if I want this to be persistent, no, don't forget to modify this file, the etc hostname. Let's put inside PC2 and the etc host. And here we are going to change Debian with PC2, which is the full qualified domain name, and the short name will be PC2. Okay, bingo, PC2 will remember its name. Now, if I look at the configuration of the Ethernet interface, it doesn't have the correct IP, it doesn't have an IPv4 address, it just have an IPv6 address, as you can see. Okay, so I need to edit this file. I should do here before IF down ETH0, which means that I shut down the interface or I disable the interface. Now that the interface is disabled, I'm going to edit the file where we have the information of the network interface. And here I'm going to change it to static. And here we are going to put address and the IP address of PC2, which is 192.168.0.20, as you can see here, no? 192.168.0.20. So the net mask is 4/24, as we can see it here. So I'm going to put net mask 255.255.255.0. And the command that I should put here is up route add net. The default route is 0.0.0.0/0 gateway. And I'm telling PC2, if you want to reach a device that belongs to a remote network, you need first to send it to R1. So R1 is 192.168.0.1. So we can do that, and it's correct. Now, Debian provides a way that is much easier, and we can just write here, instead of writing all this, we can just write gateway and the gateway that we want. So this is exactly the same. It's equivalent, but it's more shorter. It means that if PC1 have a packet for a device that don't belong to the local area network, which means that PC1 cannot reach this device directly, PC1 will have to send it to 192.168.0.1, which is this interface of router 1. So it will have to send it to router 1, and router 1 will forward it. So from now on, we are going to just write here gateway instead of up route add -net 0.0.0.0/0 GW 192.168.0.1. We are just going to type this command, which is much shorter. Okay, so I'm going to enable the interface of ETH0, And now if I type the command ifconfig, we have an IP address for PC2. So PC2 should be able to ping PC1. Let's do it to verify it. Ping 192.168.0.10, and it should work. As you can see, it is working. When you want to stop the ping, you can Control C, or you can, for example, use option like that. Send a total of 5 packets. So it will do 5 times and will stop. First time, second time, third time, fourth time, fifth time. Okay, so it did it 5 times because with the -C or -count option, I say that I want to send an echo request 5 times. Okay, so there is connectivity between PC1 and PC2. Of course, router 1 is not on for now. Okay, so let's start PC3 and let's start PC5. I don't think we really need PC4 and PC6 for this lab. So let me just start PC3 and we are going to configure PC3. So it is booting. We are going to wait a little. And let me put the information of PC3 here so we can see it well. This is PC3. So I'm going to enter as root. My password is tour as root. Okay. Let's do a persistent configuration one more time. So let me change the host name in the file /etc hostname. And I'm going to put here PC3. In the file etc host, I'm going to remove the old name and put PC3. Here I'm going to put PC3. Okay, I'm going to disable ETH0 on PC3, and I'm going to edit the file /etc/network/interfaces. No? And what we are going to do here is say we don't want to use DHCP, Dynamic Host Configuration Protocol, but we want statically to specify the information of the network for ETH0. So the address will be, as we can see here, 172.16.0.80. So 172.16.0.80. The net mask for PC3 will be /26. So 255, 255, 255, 192, no? And instead of putting the long command here, I'm just going to put gateway. What will be the gateway? What is the gateway? It will be one IP address of R1. And it's a way to tell PC3 if you want to reach a remote device, first you need to send it to R1, and R1 will forward it. So since PC3 belongs to this network, it will use this IP address of the router, not this IP address, not this IP address, but this one, because this IP address is in the same network where PC3 is. So I'm going to put 172.16.0.65, which is the IP address of router 1 in this network. So I can now enable the interface ETH0. Did I disable it previously? No, I didn't. So let me do down first and then up. Okay, so if I look at my interfaces now, for ETH0, I have the correct IP address, no? The name is still not reflected. Let me change the name here. This is PC3. Let me go out and let me come back. Okay, the name is reflected in the prompt. So PC3 is ready. Of course, if I try to ping PC2 from PC3, what will happen? Let me try to ping PC2. So 192.168.0.20. Will this ping work or it will not work? What do you think? Can I, in this moment, from PC3, can I ping PC1 or PC2? In this case, I'm trying to ping PC2. No, it will not work. Why? Because we have not even power on the router. So let me start the ping and it will not work. Let's power on the router. So the router is not a plug and play device, which means that, let me double click, the console of the router is booting. So it's doing exactly what we saw last time, which is a power on self-test. Then it go to the flash memory, find the operating system, and load the operating system into memory. It shows also a lot of information about copyrights, available interfaces. And I am done. And look at, I am seeing a prompt that I am familiar with it, which is that I'm in the user mode. When we have the name of the router greater than, we are in the user mode. So I'm in the user mode. The pings still don't work, as you can see. So I want to change the name of the router. In this moment, it is called router. This is the default name of a router. So for that, with enable, I will go to the privilege mode, and the prompt did change. So we have the name of the router on a sharp. When we have that, I am in privilege mode. Now I need to go to the global configuration mode. For that, I use the command configure terminal. And the prompt have changed. We have the name of the router, parenthesis config, parenthesis sharp. So I'm going to use the command host name to change the name. And I'm going to call it R1. As soon as I hit enter, the prompt will change and it will say that I am in R1 and I am in the global configuration mode. So it will say R1, parenthesis config, parenthesis sharp. So as you can see, the prompt have been updated and it reflects already the fact that I have changed the name of the router and I'm in the global configuration mode. Okay, so we need to configure the router. So for example, in this interface, we need to put an IP address, which is 172.16.0.65. So let me stop this ping. And let me try, I am in PC3. Let me try to ping this interface, the 65. So if I want to ping it, it will be 172.16.0.65, no? 172.16.0.65, and it doesn't work. Why? Because I have not tell this interface which IP address it have to use. So I need to go inside the interface and specify the IP address. And by default, the interfaces of a router are disabled. Then I will need to enable, and only after doing these two things, the ping that I'm running here will finally work. So let's do it. To go to the interface configuration mode, the command is interface. Then the type of the interface, it's a fast Ethernet interface and the number. So this one is fast Ethernet 0/0. So notice that in the graphic, I did not write fast Ethernet, just F. It's a short for fast Ethernet. If I write fast Ethernet, it will put too much information on the graphics and make it difficult to understand. So I don't want to overwhelm with information, and I just put F for fast Ethernet. So look, the prompt will change and will reflect that I'm in the interface configuration mode. So look at the prompt. The name of the router, parenthesis config-IF for interface, parenthesis sharp. So any command that I type here will affect this interface and not the other interfaces, because the router has three interfaces, no? It have fast Ethernet 00, the one where I am in this moment. It have fast Ethernet 20 and fast Ethernet 10. So I went to fast Ethernet 00. So what I'm going to type will affect this interface. So I want to specify the IP address of this interface. For this, I use IP address on the IP address that I want. 172.16.0.65 on the net mask. So the net mask is a /26, as we can see it here. So 255.255.255.192. So I put the IP address on the net mask. The ping that PC3 is running to this IP address still don't work. Why? Because the interface is down. It's not enabled. So let me go back to the privilege mode and show you that the interface is down. There is a command that is called show IP interface brief. And this command will show me information of the interfaces that I have. So look at Fast Ethernet 00 do already have an IP address, but it is administratively down. So I need to enable this interface. It is disabled. It is administratively down. So I'm going to go back to the global configuration mode, then to the interface configuration mode for the interface Fast Ethernet 0/0. And the command to enable an interface is no shutdown. Okay, as soon as I tap no shutdown, this ping that is not working, that is a host and destination host unreachable, should start working. So let me hit enter. I just did it. Look at the ping. The ping now is working, as you can see. If I disable my interface with shutdown, it will stop working. So look, you see, it doesn't progress anymore. It is stuck there. And after some time, it will start saying destination host unreachable. It will take some second to show it, but it will finally show it, no? Because I disabled the interface again. With no shutdown, I'm going to re-enable it. So let's wait here to see if we see the message in a few seconds. And if it takes too long to appear, I will just enable the interface again. Okay, now it's showing destination host unreachable. So it will keep showing that until I enable the interface. To enable the interface, no shutdown. As soon as I hit enter, the ping will start. So 1, 2, 3. As you can see, the ping is working again. Okay, now, let me show you. If I return here and I type the command show IP interface brief, you remember that this interface, the Fast Ethernet 00, previously was saying administratively down. Now it doesn't say administratively down anymore, it says up. When it's up, we don't have problem in layer 1 and we don't have problem in layer 2. Remember, last time that I did it, we did have administratively down because we didn't have make the no shutdown. Okay, now I go back to PC3 and I'm going to try to ping again PC2. So PC2 is 192.168.0.20 and it will not work. Why do you think it doesn't work? Look at what it says. Say destination host unreachable. Why do you think it's not working? We have not enabled this interface. So this interface is disabled. There is no way for a packet to be sent to PC2 because this interface is shut down. It's disabled. And I have not put the IP address of this interface. So I need to put the IP address of this interface and I need to enable this interface for this ping to work. So we are going to go back to router 1 and do that. So with configure terminal, I will go to the global configuration mode again. And with interface, the type of the interface and the number. So look at this interface is a Fast Ethernet. And the number is 2/0. I'm going to put 2/0. So as you can see, the prompt have changed, telling me that I am in the interface configuration mode. All the commands that I type here will affect this interface, the Fast Ethernet 2/0. So let me put an IP address in this interface. IP address 192.168.0.1. So 192.168.0.1. And the net mask is a /24. So 255, 255, 2550. The ping will still not work because the interface is disabled. So let's verify that. Here, when I'm in the privilege mode, I type the command show IP interface brief. And look, now Fast Ethernet 2.0 does have an IP address, which is 192.168.0.1, which is the correct one. But it still says administratively down, down. So since it's shut down, there is no way that a packet, that R1 forward the packet through this interface. We need to enable the interface. So for that, I'm going to type configure terminal. I am in the global configuration mode. I'm going to go in the interface configuration mode for the Fast Ethernet 2/0 interface. I am inside. And I have to type no shutdown. As soon as I do that, the ping that PC4 is doing to PC2 is going to start working. So let me do it. 1, 2, 3. Okay. Can you see the ping is working now between PC4 and PC6, PC4 and PC2, because I enabled the interface. If I go in the privilege mode and I type the command show IP interface brief, look, this interface that was previously administratively down, down, now is up, up. So it's showing that it is working properly. Okay, so we have not configured PC5. We already start PC5. Let me go in PC5 and let me start configuring PC5. So root, tour, hostname, PC5. So instead of going out to update the prompt of the bash, I can create another bash. Look, you see? When I launch another bash, which is a sub bash, a sub shell, it did update the prompt. But if I tap exit of the sub shell that I just create, the prompt is bad. So it's why I prefer to do exit like that, and I come back. And the prompt will be correct. Okay, I want to configure PC5 with its information, but I don't want the network to be persistent, the information of the network to be persistent. What should I type here? What command should I type here to say that the Ethernet 0 interface of PC5 must have this IP address, which is 10.1.150/25. What command should I type here? What command should I type in PC5 to specify an IP address on a net mask? So the command is ifconfig, the name of the interface, the IP address that you want. I want 10.1.1.150. Then the keyword net mask, then the net mask, which is 255, 255, 255, 128, because it is a /25, as you can see. So I'm going to do it. And I need also to specify to PC5 who is the default gateway, which means I need to tell PC5, if you want to reach a remote network, send it to router 1. And router 1 will take care. So the command is route add net 0000/0 gateway. And I need one IP address of router 1. Router 1 have 3 IP addresses, one here, one here, one here. Since PC5 is in this network, the gateway have to be this IP address, which is 10.1.1.129. Okay, PC5 is correctly configured. What will happen is that if I power off PC5, it will lose its configuration because I didn't save this configuration in any file. I made a non-persistent configuration of PC5. But PC5 is ready to work. So let's ping, for example, this IP address of the router here. And of course, it's not going to work for now. So it's 10.1.1.129. It's not going to work because this interface of the router is shut down and we didn't put the IP address. So it's why the ping is not going to work. Okay, so I'm going to go to the router and start continue configure the router. So here I have the ping that doesn't work and I'm in the router. Look at this interface up to now. I have no IP address. So I need to go to Fast Ethernet 01, which is this interface, and put an IP address. So configure terminal. I am in the global configuration mode. Interface Fast Ethernet 10. I am in the interface configuration mode, and I'm going to change configuration of this interface, the Fast Ethernet 10. So I want an IP address. So the command is IP address 10.1.1.129, and the net mask is /25. So 255.255.255.128. So the ping will still not work because the interface is not enabled. No, let's verify it with the command show IP interface brief. So look, previously on the Fast Ethernet 01, we didn't have an IP address. Let me show it. It is there. We didn't have an IP address. Now we do have the correct IP address in Fast Ethernet 01. In this interface, we have 10.1.1.129. The problem, the ping doesn't work because I didn't enable the interface. The interface is administratively down, no? As you can see. So I'm going to go inside the interface. First, I type configure terminal. I am in the global configuration mode. Interface Fast Ethernet 10 because I want to change the configuration of this interface. I'm going to type no shutdown. So as soon as I type no shutdown, this ping is going to work. And as you can see, the ping is working. Now, from any PC, I should be able to ping any other PC. So for example, here I am in PC5. I'm going to try to ping PC1. So PC1, the IP address of PC1 is here. So I'm going to try to ping 192.168.0.10, and it will work. As you can see, no? If I try to ping PC2, I am in PC5. If I try to ping PC2, it will work also. And PC2, the IP address of PC2 is 192.168.0.20. And as you can see, it's work. And I am in PC5. I'm going to try to ping PC3, and it should work also. So the IP address of PC3 is 172.16.0.80, and it should work. And as you can see, it's working. Okay, so I want to show you the routing table of the router and understand what it means. So there is a command that you can use to see the routing table of a router, of a Cisco router. This command is show IP route. It will show you the routing table. So look at the routing table. This information is the routing table of the router. So the router have 3 entries. On each entry appears with a C. And this C is directly connected. So we have a first entry, a second entry, and a third entry. Each line that appears with a C is an entry. So let's see the first entry, what it say, what it tells to route R1. It says If you want to reach an IP address which is in this network, 172.16.0.64/26, so this network, no? Look at what this entry say. You are directly connected. So you don't need the help of any other router. And your packet must go out this interface, the fast Ethernet 0.1.0.0. Of course, if I want to reach PC3 or port PC4, which belong to this network, I have to go out fast Ethernet 0.1. Let's see what this second entry say. So this second entry say, if you want to reach any device that belong to this network, which is the 10.1.128/25, which means this network, no? This network where we have PC5 and PC6. So if I want to, I am router 1, if I want to reach this network, look at what this entry say. I am directly connected with this network, which means that if router 1 wants to reach PC5, it doesn't need the help of any other router. And the packet will have to leave this interface of the router if it wants to reach PC5 or PC6. So the interface is fast Ethernet 1.0, which is this interface. Of course, if router 1 have a packet for PC5 or PC6, you have to send it out fast Ethernet for 1/0. Let's see the last entry in the routing table. So the last entry say, if R1 want to reach this network, the 192.168.0.0.4/24, so this network is this one, where PC1 and PC2 are connected, no? So it's this network. So the routing table say it is directly connected, which means that if router 1 wants to reach PC1, router 1 can reach PC1 directly. There is no router in between PC1 and router 1. And if router 1 wants to reach PC1 or PC2, the packet have to go out this interface, which is fast Ethernet 2.0. Okay? So you understand what is the routing table? It's just a map. What to do if I want to reach a network. Let's see the routing table of one of the PC. For example, here we have PC5. To see the routing table of a PC, we can type netstat-numerical R, which is routing table. On the routing table have two entries. So let's see. This entry. What does this entry tell PC5? So if you want to reach the network 10, if you want to reach any device that is in the network 10.1.128/25, which means in this network, for example, if PC5 want to reach PC6. So there is no gateway, which means I don't need the help of any other router. And the packet have to leave this interface. So PC5, if PC5 want to reach PC6, it doesn't use any router, and the packet have to leave this interface. So PC5 is directly connected with PC6. It doesn't need the help of any router to reach PC6. Now, the first entry is the default route. We call it the default route. So look, if you want to reach the network 0.0.0.0/0, which is the default network, you do need help of a router. So PC5 will need help of a router with this IP address 10.1.1.129, which is R1. So PC5 will send it to R1. And R1 will take care of forwarding the packet to the destination. And when PC5 send it to R1, it have to go out this interface of PC5. Of course, PC5 have only one interface, so any packet that PC5 send out have to go through Ethernet 0 because it has only one interface. This is not the case of the router. The router have three interfaces. So sometimes the packet will go out fast Ethernet 1.0, sometimes it will go out fast Ethernet 2.0, and sometimes it will go out fast Ethernet 0.0, because the router have several interfaces, but the PC have just one. So this is the routing table of PC5. Okay, let me show you that when you are in the router, you can also ping. So for example, here I'm in router 1. Let's say that I want to ping PC5. So the command is ping on the IP address of PC5, 10.1.1.150. So Cisco, by default, sends 5 packets. And if the packet is successful, we will see an exclamation mark. If the packet is unsuccessful, we will see a dot. So let me do it. Look, sending 5, and we see 5 exclamation mark, which means that they all work well. So look at the percent rate of success is 100%. Of the 5 that I sent, 5 did work well. And it shows you the round trip time, the minimum value, the average value, and the maximum value. Now, if you want to do it more than 5 times, in the PC, the option is -C. For example, let me show you again. In PC5, I want to ping, let's say, PC2, 192.168.0.20. If I do it like that, it will never stop until I Control-C it. So it will never stop. Let me Control-C it. Now, if you want to do it a certain amount of time, you use the option -C for count. Let me tell it, do it only 2 times. First time, second time. Now, in the router, the syntax is different. So if I am in R1 and I want to do it 100 times, so there is an option that is called repeat 100 times. So it will send 100 echo requests. So we will have in total 100 exclamation or point. Let's see. Okay, all of them were exclamation, as you can see. All of them succeed. Of the 100 that I sent, 100 came back. Okay, I can do, for example, do it 250 times. So it will do it a little more. Okay, of the 255 that I sent, 255 came back. Okay, minimum run trip time, average run trip time, maximum run trip time. So you can ping from a router. From the router also, let's say that you don't want to memorize the IP address, or you would like to ping like that, ping PC1. You can do it. But for that, you need to put a command in router 1. If I try to do it, it doesn't work because I didn't say PC1 is associated with this IP address. So to do that, I need to be in the global configuration mode. And there is a command that is called IP host. So here I put PC1 is associated with the IP address 192.168.0.10. Let me put another entry for PC2. PC2 is associated with the IP address 192.168.0.20. Now, previously the ping PC1 didn't work. Look now, it does work. Because I already told the router PC1 have this IP address. So when I do ping PC1, let's do it, for example, to 200 times. Let's do it 200 times, and I don't have to memorize the IP address. Okay? Now, if I try to do ping PC3, it will not work because we don't have an entry for PC3, no? So it doesn't work. Ping PC2 will work, of course, because we put an entry. So if you want to see Let me see. Show IP host. Not sure. Let me see. Show host. The command is show host. So the command show host show that I already associate PC1 with this IP address, PC2 with this IP address. If, for example, I don't want this association between PC2 and PC and this IP address, I can cancel it. How do you cancel a command? Let me go back. When I put the command, I type IP host PC2 192.168.0.20. This is what I type when I create the association. If I want to remove an association, if I type a command and I don't want this command anymore, it's no on the same command. No will cancel the command. So let me do no. Now, if I look the list of association, as you can see, we just have PC1. We don't have PC2. So if I try to do a ping to PC2, it will not work. Ping PC2 doesn't work anymore because I removed the association. Okay? So now that we have configured a little the router, all what I've typed is in RAM. All the configuration command that I've typed is in RAM, which means that if we power off the router, we will lose this configuration. So if I want to see the configuration, there is a command that is called show running-config. It will show me the running config, which is the actual configuration file, which is in RAM. So in this file, of course, look at the association that I did with PC1, it's still there. The one of PC2, I cancel it, so it does not appear. We will have the information of each interface. So look at, in the fast Ethernet 0/0, I did type this command, so I see it. In the fast Ethernet 10, I did type this command, and in the fast Ethernet 20, I did type this command. So I see them. The problem is that if I lose power, or I shut down this router, I will lose my configuration. So there is another file that is called the startup config. So the startup config is stored in NVRAM, non-volatile RAM. It's not stored in RAM memory. So let me show you the startup config. It will not have the association between PC1 and PC2, and it will not have information about the IP address that I put in the fast Ethernet 00, fast Ethernet 0, fast Ethernet 10, and fast Ethernet 20 in the router. I do it again, and this information does not appear. So if you want to save your configuration because the configuration is correct, if for one reason you have to power off the router, you want the router to remember the command, you need to type here copy running config into startup config. So copy what is in RAM to NVRAM. Let me do it. It asks me to confirm the name of the file. Are you sure you want to do that? Yes, I want to do it. So now if I go and show the initial configuration file, which is the startup config, it will be a copy of the running config. So it will have the association between the name PC1 and this IP address. It will remember that its name is R1, and it will have the information of the configuration of the three interfaces. So as you can see, we can see here that interface 00 have this IP address and this net mask, which means that if I power off the router, when it's come back, it will be just perfect. So let's do it. So you can view it. So before I do that, from PC1, I'm going to ping PC2. I'm going to ping PC3, sorry. So 172.16.080, which means that the ping do that, no? Because it's go from PC1 to PC3. So PC1 send it to router 1, and router 1 send it to PC3. And the return path is PC3 to the router, and the router to PC1. So it does work. If I power off the router, the ping will stop working. So let me show you. Here I come. I'm going to power off the router. And the ping has stopped working. Look, it's almost, we are in 27, sorry. And it will stay in 27 for some second and start showing a message of destination unreachable. No, it can take some second. We can wait. If it takes too much, I will just power on the router again, and the ping will continue. So let's wait for a few seconds to see if we finally see the message destination unreachable. Okay, it's take a little more time at this level of the router than in the PC, but let's wait. During all this time, it's trying to send. PC1 is trying to send packet to PC3. Oh, look at destination host unreachable have appeared now. And look at, this is from 27, this is 75. So all between 28 and 74 were not reported because they were lost. Now it starts to report. So what I'm going to do, I'm going to power on the router. And as soon as the booting of the router has finished, as soon as the router is totally powered on, the ping should continue working. So let me power on the router. It is booting. Let's see the booting process here. And let's see the ping here. So the booting process, oh, the ping is already working, as you can see. So the booting process is still going on, but the ping is already working because the router already have set up this IP address, those IP address on the interface. And look at, it's remember its name. If I go to the privilege mode and I show the command show IP interface brief, the three interfaces will have an IP address, and the three interfaces will be up. So look, the three interfaces have an IP address. This is the second column, and the three interfaces are up. So the ping, of course, have to work again. Okay, let me show you things that we used to do in the past. So in the past, the router was in a wiring closet, maybe 1 mile from here. Of course, I don't want to go to the wiring closet, and I am the administrator. Let's say that my office have PC1. So from PC1, I need to go inside the router and to be able to configure the router. So there is a protocol that is called telnet. And telnet allows me to make a remote session. So let me try to make a remote session to router 1. For that, I'm going to type telnet and one of the IP address of router 1. It doesn't matter which IP address. So let me choose, for example, this one, but any should work. 192.168.0.1. Look, and the router did answer, which means that the router have the port open. But the router say, okay, if you want to enter with telnet, first, you need to specify a password. When we configure the router, we didn't put any password. We didn't say, if somebody tried to telnet to you, the person have to present this password. So of course, the router is working. The router have this port open, but it doesn't allow me to telnet. So because I didn't configure the telnet daemon on the router. So I'm going to go back to the router and configure the daemon. So for that, I'm going to type configure terminal on line VTY 0. Let's do 00. I can do 00, 01, 02, 03, 04. If I do 00, there is only one line. If I do 01, there are two lines, line 0, line 1. If I do 0, 2, there are 3 lines, 0, 1, and 2. If I do 0, 3, there are 4 lines, 0, 1, 2, 3. I'm just going to create 1 line. So 0, 1 is 1 line, or it's minimum 2 line maybe. Okay, maybe 0, 1 is just 1 line. So I put 0, 1, and I'm going to put a password. Let's say that the password that the user have to type is, let's put Jacksonville. Jacksonville. And there is another command that is logging. So now I'm telling, if somebody telnet inside the router, it will have to present the password Jacksonville. So let me try it again. Previously it didn't work. So let me try to telnet again into the router. I am in PC1, and I try to connect to the router to be able to change the configuration of the router. So this time, look what happened. It's telling me, okay, I'm ready, but you have to show me that you know the password. If you know the password, of course, you can go in. So the password was Jacksonville. I'm going to type Jacksonville, Jacksonville, and look at the prompt. I am in the router. I am not in PC1 anymore. So the command that I will type here are commands that will affect the router because I'm not in the PC, but the router. So for example, if I do show IP route, it will show me the routing table of the router. When I'm done, I will just type exit. So the good thing, I didn't have to walk up to the wine closet where is the router. From my office, I can make a remote session into the router and change its configuration or view its configuration. When I'm done, I exit, and as you can see, I came back to the PC. So here I am in the PC, and if I want to see the routing table of the PC, the command will be this one, net statistic -n for number, R for routing table. And this is the routing table of PC1, as you can see. So as you have seen, we have not created a user. When I connect, let me do it again. When I connect, it didn't ask me a username. It just asked me a password, and the password is Jacksonville. So let's do something that is a little better. When I work like that, if I have 3 administrators, they will share the same password because there is no user. There is just one general user without logging. So if I want to create user, specific user in the router, I can create them with the command username. So let's create a user that is called Eric, for example, in the password in the router, and let's put as password. Let's put Eric to make it easy. Eric pass. Let's put Eric pass. Let's create another user. Let's call it Michelle. And here we are going to put Michelle pass as password. Okay, I have 2 users now in the router. So let me go back to the configuration of telnets with line VTY01. And previously I did logging, just logging. This time I'm going to type logging local, which means that there is a database of user, which is local to the router. If somebody wants to connect through telnet, check that the credential that the person presents correspond to the database that we have in the router. So let me try now to connect to the router with telnet. This time it will ask me the username and password. So let's do it. Look, previously it didn't ask me the username, but since I create users now, It asks me the username. So let's say I am Eric. It asks me my password. I'm going to type Eric pass. And I am in, as you can see. So Michel is another administrator and work on PC2. So Michel is going to try to access the router also. So for that, it's a telnet on one IP address of the router. Doesn't matter which IP address. So let's take any IP address. Let's take this one, 192.168.0.1. And look, the router answer and challenge Michel to show that Michel is a legitimate user. So it say, please tell me your username. Let's put Michel. And say, please give me your password. Michel pass. Of course, if I have these two information correct, it is good. Now, what I wanted to show you is that we allow two telnet sessions at the same time because we put 0, 1. So if there is a third user that wants to enter the router, it will not be allowed because there is already two stations. So let me create a third user. With the command username, we are going to create Robert, for example. And the password of Robert, to make it simple, let's put Robert pass. Robert pass. Okay, so Robert, for example, work in PC3. And Robert want to telnet the router. So any IP address of the router is okay. 192.168.0.1. So this time, Robert will not be allowed because I permit two telnet sessions parallel. So look what will happen. You see, it's closed. The router closed the session. Does not allow Robert. Why? Because there is already two users that are connected. Now, let's say that Michel exits. There is only one user connected in this moment. So Robert can go in. So this time, if Robert try it, look at, give me your username, Robert, give me your password, Robert pass, and Robert is in the router. Now, if Michel tried to come back, since we allow only two sessions in parallel, Michel will not be able to come back, no? You see? It closed the session. Does not allow. So let's see something. Telnet is a very old protocol. So Telnet, unfortunately, was made in 1970, many years ago. And when they did Telnet, security was not an issue, which made that the password and the login of the user are sent on the network in clear text. So let's say that you have somebody in your network that want to do damage to Robert, for example, the user Robert that work on PC3, or want to do damage to the company. So this person can sniff the network. Let's simulate that this person is going to sniff the network. So I'm going to sniff here. So I'm going to put what we call a sniffer, like Wireshark. So start capturing the traffic. So it's going to start capturing the traffic in this link between the router and the switch. So those are the packets that travel. They are captured here. So let's say that Robert wants to connect to the router. So it typed the command telnet, the IP address of the router. They ask, what is your username? Look at the traffic, the telnet traffic here in Wireshark, no? We can see that we have a telnet traffic. So I'm going to put my username. I am Robert, so I'm going to put Robert. And then it asks me, what is your password? So I'm going to put Robert pass. And I'm in. So look at the hacker. the hacker have made the capture. So the hacker can stop the capture and study the capture with more time. On Wireshark, so this is the conversation between PC3, which is the PC of Robert, and the router. So Wireshark have an option. You go over a TCP packet, and there is an option that is called follow TCP stream. And it will show you the conversation at a higher level. So this is the conversation at a higher level. So look, when the router asks Robert, what is your username? Robert type Robert. When the router asks Robert, what is your password? Robert type it Robert pass. So as you can see, the hacker can get the logging of Robert and the password of Robert. So we should not use Telnet to do remote session because the password, as I just showed you, travel in clear text. It is not encrypted with an encryption algorithm. So let me stop the capture here. What we are going to do is, let me disconnect here. Robert is disconnected now. Let me disconnect the user Eric. I'm going to go back to my router and disable Telnet and enable Secure Shell. So Secure Shell is a much recent algorithm, and this one encrypts and have strong encryption, very strong encryption. So even if the hacker captured the traffic between the PC of Robert and the router, he will not be able to understand the conversation because the conversation will be encrypted. So let me configure the router. So the router now stop using Telnet and start using Secure Shell. So for that, I'm going to type, I need to define the domain name of the router. So IP domain name, let's say that our domain name is jsu.edu. Okay, after this command to enable Secure Shell, I'm going to type crypto, because we are going to use cryptography, key, generate. Oh, this router that doesn't have cryptography. It's an iOS that doesn't have cryptography. So bad. I will not be able to type this. I need another router to do this practice. So unfortunately, I will not be able to enable Secure Shell on this router. I will have to replace it. Okay, let's do it. Let's replace it and see how it will work. So let me power off the router, remove this router. It's obsolete. It was good for some years, but now the world is much more dangerous. I'm going to buy a better router. For example, I hope this one has cryptography inside. So let me put it here, which is 3745. Let me open it. In the slot, it already has some cards. Let me see if this one has support for cryptography. Let me see in the slot. You also have already some. Let's do it. No problem. We'll do with that. No, not an issue. So I need to connect Fast Ethernet 2.0 to this one. I need to connect Fast Ethernet 0.0 to this switch, and I need to connect Fast Ethernet 1.0 to this switch. Okay, by the way, this option shows you the name of the interfaces. So it can be useful because you see the name of the interfaces. Let me power on the router, and let's see if the router has cryptography options. Yeah, I think it has cryptography option because it's an advanced iOS. So let me configure it rapidly. Enable, configure terminal, hostname router1. I'm going to go to the interface fast Ethernet 00 and put the IP address, which is 192.168.0.1/24. No shutdown. Okay, I'm going to go to the other interface, which is fast Ethernet 10. The IP address is 10.1.1.129. And the mask is 255.255.255.128, which is a /25. And I need to configure the third interface. So interface fast Ethernet 00, IP address 172.16.0.65, and it's a /26. So at the end it will be 192, no shutdown. Okay, let me verify the interfaces with show IP interface brief. Okay, so they are up. There is one. I did something wrong. Let me see. The fast Ethernet 00 have the correct IP address. The fast Ethernet 10 have the correct IP address. I didn't go to the fast Ethernet 20 maybe. So configure terminal, interface fast Ethernet 20, IP address 192.168.0.1.255.255.255.0. No shutdown. Let me see if I went inside this interface. Oh, when I try to do it, I put the wrong interface. You see, I put it in 00. It's why it didn't work. Okay, so now it should be okay. So we have three interfaces with IP address and it is up. So let me go and try what I was trying to do. So IP domain name jsu.edu and crypto, we do have it. Crypto key generate RSA, reverse Shamir Adelman. How many bits I want in the key? Let's put a key of 124 bits. So it generated a pair of keys. And secure shell have been enabled, as you can see. So I need some user. So I'm going to recreate the user Eric in this router. And the password will be Eric password. And I'm going to go again with line VTY 01. And I'm going to type logging local to tell that there is a database of user locally in the router and I want to use it. And also there is a command that is important, which is the transport input. The transport, okay, I'm not going to do it for now. So in PC1 we have Eric. Let's see if Eric can telnet the router. It can telnet the router. I need to disable that. I put Eric password. So I need to disable that. And let's see if Eric can secure shell the router. Secure shell. So it's telling me I get the certificate of the router. Do you agree to store the certificate of the router in your PC? I'm going to say yes. Oh, it asked me the password, but it didn't ask me the user. So let me put here, the user will be Eric at. So it asked me the password. I'm going to type Eric pass. So I could secure shell also. So both are enabled. If you want to just keep secure shell, here you go in line VTY, for example, just 2 sessions, and you are going to use the command transport input. So in this moment, it's allow telnet and secure shell. So I'm going to say just secure shell. So now, if Eric try to telnet, it will not allow it. You see, it closed the session because I say I didn't allow telnet. But if Eric try to secure shell, it does allow. The password is Eric pass, and I'm in, and I can go out. So now, to finish, if we capture the traffic between PC1 and the router, the traffic will be encrypted. So let me start a capture, and let me try to secure shell again. So it is captured secure shell, as you can see, secure shell version 2. It asks me my password. Let me put it's Eric password, sorry. Eric pass, and I'm in. So there is traffic here. The hacker has captured the traffic, and the hacker tried to follow the TCP stream. And look, things are encrypted. I cannot see the password. So there is no way here that you can see the password Eric pass, because it is encrypted. So it's why we should not enable telnet in a router. And if the administrator want to access the router remotely, they have to do it with secure shell. Okay, so remember that if I want the configuration of the router to be persistent, this is a new router. In the old one, I did it. I will have to do copy running config to startup config. So now, if I lose the power on router 1, it's not a problem because when it's come back, it will have all the configuration. Okay. When you are done with, for example, this lab, remember that your PC are on. You need to shut down your PC. You can do it with init 0. Here I'm going to stop PC1. I'm going to do the same thing with PC2 with init 0. I'm going to do the same thing with PC3 with init 0. I'm going to do the same thing with PC5 with init 0. So now PC5 is still on, it's green, it became red. So all of them are in red except the router. Let me stop the router. Okay, now remember you don't need to save in GNS3. You can leave. And you can come another day and continue with the practice, no? So I can say, I need a practice that is already there. This is the practice that we did. Double click the GNS3 file, and it will open the same topology, and I can put the device on again, and everything will continue where I left. Okay, so this tool is very powerful. Very, very powerful. So please try to do some of the labs. Okay, I think, as I told you, next week we have the first quiz on Tuesday, and we have the exam on Thursday. So be ready. What will go into this exam is all that we have seen so far. There will be, to tell you the truth, there will be no question about configuration of devices, but all the rest will go. Okay? Okay, so I see you next week on Tuesday for the quiz.